You open a chat window and type a question. A second later, you get an answer. It feels like nothing. Weightless. It wasn't. That answer just traveled through a building the size of a football field, where tens of thousands of chips run day and night, and a single cabinet of them can pull more power than a whole street of houses. And right now, all over the world, people are racing to build more of them, faster than the ground can be cleared. So let's go inside. For years, the cloud was easy to ignore. It sounded soft, amorphous, far away, someone else's problem. Then AI arrived and made the cloud impossible to ignore because it made it enormous. To give you some scale, the International Energy Agency estimated that data centers used around 415 terawatt hours of electricity in 2024. That is roughly 1.5% of all the power on Earth. By 2030, they expect that to more than double. In the United States, Lawrence Berkeley National Labs found that data centers were about 4% of the nation's electricity in 2023 and could climb to as much as 12% by 2028, not over a generation, in 5 years. Now, 1.5% of the entire world's electricity sounds kind of small. Aluminum smelting alone uses more than twice as much electricity as every data center on Earth. Steel production, about 3 times more. Data centers are not the largest consumer of energy right now, but they are the fastest growing load on the grid. And most of that new demand isn't coming from you checking a chatbot. The biggest customers are the companies themselves. Microsoft, Google, Amazon, Meta. They're training the next generation of models, and training is where the real demand lives. Training a single frontier model, a GPT-4, a Gemini, a Claude, a Llama, can take months on tens of thousands of chips running around the clock. Then there's inference. Every question everyone asks hundreds of millions of times a day. AI lands on top of cloud computing that was already there, and a lot of what's being built is a bet on demand that nobody can prove yet. So, what's actually in there? Walk inside one of these buildings, and the first thing that hits you is the sound. A wall of fans, cold air pouring across your face, and a row of black cabinets stretching further than you can see. Each cabinet is a rack. Each rack is packed with GPUs, the specialized processors that do the thinking. Almost all of them are made by NVIDIA. A normal server rack, the kind that ran ordinary websites for years, drew maybe 5 to 10 kilowatts. One of NVIDIA's newest AI racks pulls around 120. That's a 12-fold jump packed inside of a box the size of a refrigerator. And that creates a very physical problem: heat. Pack chips that close together and fans simply cannot move air enough to keep them from cooking themselves. So the industry is doing something it resisted for years. It's running liquid straight to the chip, or submerging entire servers in special fluid. The most advanced computers on the planet are now cooled like a car engine. Cooling, though, turns out to be the easy problem. The hard one is power. So the AI companies went looking for electricity at the source, and this is where things get interesting. In 2024, Microsoft signed a 20-year deal to restart a reactor at 3 Mile Island, the site of America's most famous nuclear accident. 835 megawatts brought back to life to feed data centers. Weeks later, Google agreed to buy power from a new kind of small nuclear reactor, and Amazon backed another one. Software companies suddenly are in the business of buying nuclear power. Some couldn't even wait for that. When Elon Musk's xAI built its Colossus supercomputer in Memphis, 100,000 chips, the whole thing went up in about 122 days. They wheeled in portable gas turbines because the building was done before the grid was ready for it. This is happening everywhere, but every region in the world solves the same problem with whatever it has the most of. In the United States, the answer is scale and money. The Stargate project, announced in early 2025, put a number on it that still reads like a typo. Up to $500 billion, starting with one mega campus in Texas. In Europe, the space is tight and the grids are smaller, so builders have to get creative. Ireland's data centers now eat around a fifth of the whole country's electricity, and the grid operator in Dublin effectively stopped taking new ones. In Denmark, a Meta facility pipes its waste warmth into a district heating system for roughly 11,000 homes. In Asia, Singapore paused new data centers entirely, then reopened only the most efficient designs. In the Middle East, it's the opposite. The Gulf is building some of the largest data center campuses on Earth out in the desert, where the hardest job is keeping them cool. India is building fast too, and the challenges run deep. Google, Amazon, and Microsoft have all committed billions to build there. Mumbai alone holds over half the country's data center capacity. But a single 100-megawatt facility can drink 2 million liters of water a day, and more than half of India's data centers sit in water-stressed regions. Add tropical heat that pushes cooling systems to their limits and a power grid that still needs major updates, and you can see why money alone doesn't solve it. And then there are the people who want to leave the ground entirely. Companies like Lumen Orbit are designing data centers that would orbit the Earth. The pitch, unlimited solar power, no land, no water, and the vacuum of space as a cooling system. In 2025, Lumen Orbit launched a satellite with an NVIDIA GPU on board and actually trained a language model in orbit. After merging xAI into SpaceX, Elon Musk claimed that the cheapest place to run AI could be space within a few years. Nobody has built a full orbital data center yet, and the launch costs are still tremendous. But for the big, slow jobs like training a model over months, the speed of light delay doesn't matter. Those workloads just need chips and electricity, and space has both. The fact that serious money is moving in that direction tells you how hard the problems are down on Earth. So back on the ground, there's a question worth asking. What is all this money actually buying? We've been told the story of AI as a story about intelligence, smarter models, better math, more clever algorithms. But the four biggest companies are pouring north of $300 billion in a single year, and most of it goes into buildings, land, power, and pipes. The mind is improving faster than we can build the body to hold it. The bottleneck stopped being software. It became concrete and copper and cooling water. And there's an honest argument going on right now about whether we're building too much. In January 2025, a small Chinese lab called DeepSeek released a model that was startlingly efficient, and the market flinched, erasing around $600 billion of NVIDIA's value in one day. If AI can be made that much leaner, do we really need all this steel? Nobody knows yet. What we do know is this: smaller models now match what massive ones did a year ago at a fraction of the power. Google used AI to cut its own data center cooling energy by 40%. And remember how Meta in Denmark pipes its waste heat into homes instead of dumping it? Microsoft is building the largest version of that in Finland, designed to help heat 250,000 people. Total consumption will still grow. Make something cheaper, and most people will use more of it. But the thing consuming all this energy might also be the best tool we have for learning to generate it cleaner. And we have seen this shape before. Electricity had it, the railroads had it, the internet had it. Every technology that ended up everywhere went through an awkward, expensive phase where the world had to be physically rebuilt to carry it. Ugly infrastructure poured in a hurry so the elegant thing could run on top of it. That is what these buildings are. The weightless answer on your screen is the thin, bright surface of the largest construction boom of our lifetimes. And how we build it, whether the power is clean, whether the heat gets reused, whether the water is spent with care, is what decides whether the trade was worth making. The intelligence gets all the attention. But for now, the real race isn't to think faster. It's to build fast enough to keep up with the thinking.